And now we move towards our next presenter, Sheraz Hussain. He is from UET Taxila. Shiraz, are you with us? And he will be talking about a role of sacrificial piles on reducing local scar around the bridge abutments. Shiraz, are you with us? Walaikum assalam. Shiraz, please share your screen. Okay, we can see your screen now. Please go ahead. Again, as a reminder, please conclude your presentation in 10 minutes. You can skip the literature review and focus on your work and results, please. We're not getting your voice.
Are you getting my voice?
Yes, now please speak loudly, a little bit loudly.
My name is Sheraz Hussain and my research supervisor is Dr. Ghufran Ahmed Pasha from University of Engineering and Technology, Taxila. And my research topic is the role of sacrificial piles on reducing local cover around bridge abutment. Table of content: introduction, problem statement, research aim and objectives, proposed methodology, results and discussion, conclusion and references. This is my introduction, and due to time limit, I have to skip it and I am going to problem statement. Flash floods mostly occurred in hilly areas of Pakistan. Due to this discharge, and the river becomes high and extremely turbulent. Therefore, structures like bridge abutment and piers in the path of river face large impact and hydrodynamic forces. Greater the turbulence, greater is the bank erosion and abutment scouring. As a result, bridge may collapse due to excessive scouring. Research aim and objectives. Aim of this research is to reduce local cover around bridge abutment by using submerged and immersed sacrificial piles with different aspect ratio. The main objective of this investigation are to investigate the local cover around bridge abutment by using submerged and immersed sacrificial piles, to study the effect of aspect ratio of sacrificial piles on local cover, to study the effect of different G by D ratios of sacrificial piles on reducing local cover. Methodology. All the experiments was performed in the Water Resources and Hydraulics Engineering Laboratory of Department of Civil Engineering, UT Taxila. The channel had specification of 20-meter length, 1 meter wide, and 0.75-meter deep glass-sided flume with an adjustable tailgate at the channel end to regulate the flow depth used for the experimental depth. All experiments were conducted at two different discharges, 0.023 and 0.027 meter cube per second, having Froude number 0.136 and 0.162 respectively. This is a schematic view of laboratory channel, that the bridge abutment is placed in the middle of the channel and sacrificial piles are placed upstream the bridge abutment. Total 20 experiments were performed in the laboratory channel using sand as bed material. The tests were performed on trapezoidal bridge abutment using sacrificial pile with different aspect ratios. A 3-hour equilibrium time was maintained for each test. At the end of every test, the flume was slowly drained and the scour hole was measured with point gauge. Results and discussion. Firstly, scouring without sacrificial piles protection. Initially, the trapezoidal bridge abutment was tested without any sacrificial piles protection. The maximum cover depth around trapezoidal bridge abutment was 16.74 mm and 18.5 mm respectively. These were against the fraud number 0.136 and 0.162. And the comparison of longitudinal profiles of trapezoidal bridge abutments for the two different fraud number 0.136 and 0.162 are shown as the value of fraud number increases from 0.136 to 0.162, the value of cover depth also increases, as we can see in the graph, like figure 5, that when we increase the fraud number from 0.136 to 0.162, the cover depth also increases. So, scour reduction with sacrificial piles protection. The trapezoidal bridge abutment was tested with provision of sacrificial piles protection with different aspect ratios and different G by D ratios. The percentage reduction in maximum scour depth for trapezoidal bridge abutment against fraud number 0.136 and 0.162 are 70.13% and 67.56% respectively. Hence, it is found that for trapezoidal bridge abutment, sacrificial piles arranged with 0.75 aspect ratio and 1.4 G by D ratio against fraud number 0.136 has a greater reduction of scour depth. And these are the graph that shows cover depth comparison at different aspect ratio and different G by D ratios at discharge Q1 and discharge Q2. From the graph, we can see that when we decreases the value of aspect ratio from 1.7 to 1.1, 1.7 to 1 and 0.75, our scour value reduces. And like this, if we reduce the value of G by D from 2.85 to 2.14 and 1.4, the scouring also decreases. Scour reduction efficiency of sacrificial piles protection. The efficiency of the suggested countermeasure for abutment is determined by the percentage reduction of scour depth at the upstream base of abutment with these detail. E is equal to DUP minus DSP over DUP multiplied by 100. DUP and DSP denote the maximum scour depth measure at the unprotected trapezoidal bridge abutment, and DSP denotes bridge abutment protected with sacrificial piles, respectively. From figure 7a and b, it is observed that maximum percentage reduction for the sacrificial pile provision is when sacrificial pile are placed with aspect ratio of 0.75 and G by D ratio of 1.4. These are the graphs for efficiency of scour reduction at discharge Q1 and the efficiency of scour reduction at discharge Q2. So scour reduction efficiency increases as we decrease the aspect ratio, and also the scour reduction efficiency increases as we reduces the G by D ratio. Conclusion. Scour reduction at bridge abutment is significantly impacted by sacrificial piles. With a lower G by D ratio, the incoming flow encountered greater resistance, which led to a substantially larger scour reduction under the same flow conditions. According to experimental findings, the scour reduction was maximum in dense sacrificial piles arrangement. Considering the sacrificial piles arrangement with aspect ratio 0.75 and G by D 1.4, the average scour depth reduced by 70.13 in comparison to scouring without sacrificial piles. These are my references. Thank you, sir. That's all from my side.
Thank you very much, Engineer Sheraz Hussain, who was presenting the results on the sacrificial piles through model studies at UT Taxila. With